So as I said in the last video, we are going to get a little bit more complicated now, but I know you guys will get through it because you're very smart. So the last one was focused specifically on proportions and solving them via cross products or cross multiplication. Cross multiplication. This one is focused on rational equations in general, ones that are not proportions. So, again, just a reminder, cross multiplication is defined as if A over B equals C over D, then A times D equals B times C. This only works when we have one ratio, only one fraction set equal to only one ratio, only one fraction. There can't be any other stuff involved. These fractions can be as complicated as they want to be, but we cannot have, for example, 2 plus A over B equals C over D and be able to do cross multiplication. It only works when we just have a fraction equals a fraction, and that is it. So sometimes we will have situations where we can't immediately cross multiply, and that means that we have to do some manipulation. So if we had, for example, 7 over x minus 1 over 3x equals 5 over 3. Now this is not just a fraction equals a fraction, we have this other fraction involved. So we have to deal with that. Since this is not in the A over B equals C over D form, we have to put it into that format before we can cross multiply. This is going to involve actually doing that subtraction. So subtracting 7 over x minus 1 over 3x. So we know how to do rational subtraction. We have to multiply anything by what it doesn't have. So the 7 over x, between x and 3x, this one's missing 3. So we have to multiply 7 over x by 3 over 3. Simplify that to get 21 over 3x minus 1 over 3x. We still have that equals 5 over 3. Further simplify, 21 minus 1 is 20 over 3x equals 5 over 3. Now we can cross multiply. So 20 times 3, 3x times 5. Simplify that, we get 60 equals 15x. Divide by 15, we get x equals 4. That is one way of solving an equation like this. The other way is a little bit more complicated or a little bit less complicated depending on your perspective. We'll talk through it. So if, for example, we were given a problem such as 9 over 2 plus 3 over 2x equals 6. Similar setup to the last one, but now we just have that plain number there, but again, any whole number is itself over 1, so we can just make that 6 over 1. If we like that format better, which I do for what we're about to do. So another way of solving rational equations that are not already in the proportion form is to use the common denominator of all terms to clear out or cancel the fractions. Nobody really likes working with fractions, so if we have the opportunity to cancel them out, some people will jump on that opportunity. The first thing we have to do is find the LCD, or the least common denominator of all terms. And as we've talked about, it doesn't have to be the least common denominator, it just has to be a common denominator. But again, with rationals, we do have to be careful that we are looking at the common denominator as the right thing. It's really easy to fall into a trap of an incorrect common denominator. An incorrect common denominator. There it is. So between 2, 2x, and 1, our least common denominator is going to be 2x. Because this one's just missing the x, this one already has the 2x, and this one needs both parts. But the 1 is easy to work with. So we would then multiply all terms in the equation by this least common denominator, or just common denominator, depending on what we're doing. So again, our least common denominator here is 2x. So we multiply 9 over 2 by 2x over 1. Then we have 3 over 2x times 2x over 1 equals 6 over 1 times 2x over 1. We are now able to multiply by the least common denominator over 1. Now, when we weren't able to do this before, because when we were strictly adding or subtracting before, we did not have an equation. Oops, bumped it. We couldn't do that because we didn't have an equation to do things on both sides to. When we have equations, we can do anything to them as long as we do it to both sides of the equation. So here, now that we do have an equation, we are able to multiply everything by just 2x because it doesn't change the value of the equation. Doing the same thing to everything keeps everything in balance. So as opposed to when we were just adding or subtracting, we had to multiply by 2x over 2x. That is no longer the case because we have equations, because we can do it to both sides. Be very careful. It is extremely easy to forget which one is which. When we are just adding or subtracting, we don't have an equation. Then we have to do the same thing in the top and the bottom, multiply by the same thing in the numerator and the denominator. When we have an equation, we can just multiply in the numerator because we're doing the same thing to all terms in the equation. So continuing this problem, we can now, this doesn't look necessarily simplified, but this is how I'm writing it out because that's how it's making sense to me. We had 9 over 2 times 2x over 1 plus 3 over 2x times 2x over 1 times 6, or equals 6 over 1 times 2x over 1. What I'm going to do now is kind of separate things out in a way that we can clearly see when the denominators are going to cancel. So we had 2 times 9x over 2 times 1. Those 2's are now going to cancel. 2x times 3 over 2x times 1. The 2x is going to cancel. And then 2x times 6 over 1, that just stays. So now we just have 9x over 1 plus 3 over 1 equals 12x over 1. And we can drop the over 1 because anything over 1 is just that number. So now we don't have any more fractions. We just have 9x plus 3 equals 12x. And we just solve this like a regular equation. So I'm going to subtract 9 from both sides, 12x, or 9x, sorry, and get 3 equals 3x, which means x equals 1. Now these problems you could do either way. You could multiply by the LCD and get rid of the fractions if that's what makes more sense to you. Or you could do what we've been doing, which is cross-multiplying, getting it so that they have anything that is not just one fraction on one side, make that a common denominator, add it together, and then cross-multiply, but you might end up with bigger expressions, uglier numbers that you might then have to factor. So you can do it either way, whatever makes most sense to you. Delta Math, going through these problems, it's going to prompt you to multiply by the least common denominator. So the one we just did is like the first section in the Delta Math rational equations practice. A slightly harder one, but slightly shorter. And this rule still works with more complicated least common multiples. So this is like the section 2, what we're about to talk about here. So we're given negative 9 minus 1 over x minus 5 equals negative 5x over x minus 5. We can take a look at this, see that that's, negative 9 over 1, technically. So 1 doesn't really make a difference with our least common multiple. It's just a nice blank slate. We have x minus 5 and x minus 5, so it looks like that's what's going to be our least common multiple. So now we multiply everything by the least common multiple. So negative 9 times x minus 5 minus 1 times x minus 5 over x minus 5 equals negative 5x times x minus 5 over x minus 5. Again, we can multiply only the numerators now because we're doing the same thing to all terms in the equation. So those are going to cancel out. Those are going to cancel out. We're just left with negative 9 times x, which is negative 9x, negative 9 times negative 5, which is positive 45. Don't forget this one here. Again, like when we were simplifying before, when the numerator and the denominator cancel out, we still have 1 in there. They cancel to 1. They don't cancel to 0. So do not forget that that is a negative 1 that we need to bring down. It's easy to forget that. And then again, the x minus 5 over x minus 5 here cancel, and we're just left with negative 5x. So let's see. Negative 9x plus 44 equals negative 5x. Bring the negative 9x over. Oops, sorry. 44 equals 4x. Divide by 4. X equals 11. Again, you can use either method. I do think that the least common multiple method can be a lot more simple, but if that is not your preference, you are more than welcome to do the, adding these and then using cross multiplication. Whatever makes most sense to you.